This segment covers the simplest example of a Haskell data type, that is an enumerated type. When we started talking about different kinds of compound types, we talked about representing things like colours or seasons, and that's what I want to do in this section. So if we wanted a type of the three primary colours red, green and blue, we can define it like this. We say data, that signals that we're defining a data type, and then we give the name of the type, which begins with a capital letter. We follow that with equality, and then we give the values in the data type, which all again begin with a capital letter, separated by a vertical bar. So that says there are three values in this type: red, green and blue. And the values in that type are precisely those three things. Now, if we try and, after we've input the data type definition, if we try and evaluate red, we get this error. And it's saying no instance for show color. This is one of these overloading error messages. And it's saying that there is no way of showing this or printing out this value that we've asked for. Now, what we can do to remedy that is we can add this line that says deriving show and EQ. And what that does is to get the system to automatically produce definitions of a show function, that is a function that will turn a value into a printable form, and an equality function. And as you can guess, the show function and the equality function do exactly what you would expect. That red is not equal to green, but red is equal to red, and that showing the value red results in the string capital R ED, as you can see here. So this is again an example from GHCI. If we say evaluate red, the answer is printed out as red. And if we say is red equal to blue, we get the answer false. Now we have chosen to use deriving. It's possible, and I'll show this a bit later on in the next segment, I think. It's possible to define your own show function on your own equality function if you wish. But given the system will derive these correctly for you, there seems little point in doing that. Let's look at a couple of other examples. If we wanted to define the seasons, we could say data season, and then we have the four values: spring, summer, autumn and winter. And we could have a type of temperatures: hot and cold. And again, we separate the values with vertical bar, and in both cases we've added a deriving clause so that we can print them out and check for equality. How do we define functions over these enumerated types? We've already seen a lot of examples of that in defining Boolean functions, but here's a simple function that tells you the temperature of the season, at least in the UK. It says that it's hot in the summer, and at any other time, I'm using the underscore to pattern match there, it's cold. So to define values over an enumerated type like this, we use pattern matching. We say for the particular value summer, the result is hot, and if we apply temp to something which doesn't match summer, the answer will be cold. So that's pretty much it for these simplest of types. We can define a finite range of values in this way. Type names begin with a capital letter. The values in the types begin with capital letters. And that's it.